Hello friends, welcome back my YouTube channel MS Maths. In this video, we'll discuss the application of the Bernoulli's equation. So what is the Bernoulli's equation that we have already discussed? The Bernoulli's equation is basically the 1 by 2, or we can write in this way the Bernoulli's theorem. Bernoulli's equation is the pressure upon density into gravity plus velocity is basically, we'll write it as q1, or basically q vector upon 2g plus z, or basically the h. So in this way we can understand the concept of the Bernoulli's equation. So it is nothing but that we have already discussed that what is the Bernoulli's equation, and you can watch the previous video. In this particular case, we'll use the Pitot tube. So what is the Pitot tube? It is the device used for measuring the velocity of the flow at any point in a pipe or a channel. If the velocity of the flow at a point becomes zero, then pressure is increased and the fluid will arise in a tube, and the point at which the velocity of the fluid is velocity of the flow is called basically the signant point. Okay, signant point is basically at where the flow becomes the zero. Velocity of the flow becomes 0. Okay, now the pressure at a stagnant point is called the total pressure or head pressure. Okay, so what is the working, and in this video we'll discuss and we'll find the velocity of the fluid. How will the find the velocity of the fluid? If the fluid is passing in this way and the flow direction in this way, then we'll put it at opposite side. It is your basically point 1 and it is your point 2. This is inside and this is basically the 90-degree, or the height. It is the height h, where h is nothing but depth of the tube in liquid, and where small h is basically the height of the fluid arise in this. I say the fluid goes up to with the increasing the pressure in this level. So you will consider that the fluid goes in this way. So this is the tube and the fluid goes in this way. Here is the fluid in the channel or in the pipe. Now Q1, Q2 are the velocity at this point, part 1, that is the outside the Pitot tube. P1 is the pressure, Q2 is the velocity at the flow at the point 2, and the flow at the pressure of flow at point 2. Now, by using the definition of by using the equation or Bernoulli's equation, what is the Bernoulli's equation? It is basically, here we have H and capital H, but we'll take Z1 or Z2 with the reference line. I say this is your reference line, this is your reference line, then it is basically 0. I say it is my reference line, then the height of the Pitot tube at this point and at this point, both the point, it is 0. Then I say Z1 is equals to Z2. This is the height of the tube by the reference line. So basically we will consider the Bernoulli's theorem. 1 by 2, Bernoulli's equation is 1 by 2 q1 square plus 1 by 2 q1 square plus g z1, okay, plus p1 upon rho, that is the density, is equals to 1 by 2 q2 square plus g z2 plus p2 upon rho. Here z1 is equals to z2 are the height from the reference line of the Pitot tube. Then we can cancel these two things, then it will be q1 square plus p1 upon rho is equals to 1 by 2 q2 square plus p2 upon rho. Here we have what is the P? P we can write in this way, rho GH. Okay, so we have this P by rho is the pressure head. Okay, P by rho is the pressure head, then H plus, then we can write in this way. Okay, first of all, do one thing, write it as, because the gravitational force we need the gravity, so we will write it as GZ1 plus GZ2. So we will write it as P1 upon rho g plus Q1 square upon 2g plus Z1. Then P2 upon rho g plus Q2 square upon 2g plus Z2. Then these both things will cancel. Then this is nothing but H plus Q1 square. Okay, here, wait, here it is the pressure head. P1 upon G is the pressure head. So pressure head 1, so which is the depth of the which is equal to the depth of the tube in the liquid, that is capital H, plus Q1 square upon 2G. Okay, Q1 square upon 2G is equals to, this is the depth where the pressure is P2. Because of that, how can we write this in terms of height? What is the pressure? It is rho GH. We can define the pressure in the way of rho GH, because force by some area, we can write in this way using divide by V, that is the density, and we can write it is that. So here H, or the height, is nothing but P upon rho G. So in this case, for P1 it will be capital H, and for P2 rho G it is small h. So it will be small h plus, what is this, is basically V2 upon this is basically V, or Q2 is the Q2 square upon 2G. Now we can write, we want to calculate the value of the, we want to calculate the value where the velocity will be 0, become 0, Q2 becomes 0. Okay, wait, we will find Q1 square, Q2 value will 0, pressure at point 2 in the Pitot tube, it will be 0. Then we can write this as Q1 square is equals to, basically for P2 it will be H plus H, small h plus h, because see, this is your small h, this complete length h plus h will represented by the pressure at this point P2 and pressure at this point P1. For this P2 we will write P2 as rho G H plus capital H. Okay, yeah, then it is nothing but H plus, it is your H plus capital H plus Q2 is 0. Here this term will be 0, because of that at the part of 2 the velocity will be 0, become 0, like that is the principle of the Pitot tube, that Q1 square is equals to 2GH. It is nothing but, Q1 is nothing but root 2GH. Now here Q1 actual, this is the calculated. Now what is the actual Q1? So Q1 actual is basically the CV into 2GH, which is the coefficient of Pitot tube. In the ideal case, this fluid velocity will not be 0. So there is some multiplication or some coefficient which we will use. So this is the formula of the Pitot tube. So basically in this case we have used the concept of this, the pressure is nothing but rho GH. So this is all about the Pitot tube. So thanks for watching my video. Keep watching MS Maths. Thank you. Bye bye.